All right, so get ready because today we're diving deep, way beyond like the usual DNA stuff, beyond those, those like simplified diagrams you see in biology textbooks. We're going deep into the world of energy and molecules, the stuff that actually makes life happen.
Yeah, it's really about like the fundamental chemistry of it all.
Exactly. And to guide us on this adventure, we've got Nick Lane's Transformer. And this book, let me tell you, it's gotten some serious praise from some big names.
Oh yeah, for sure. I mean, Siddhartha Mukherjee, he wrote The Emperor of All Maladies, fantastic book he called Transformer, thrilling and really persuasive.
And even like former NASA astronaut John Grunsfeld, this is a guy who's seen the planet from space. Even he was blown away. He said it illuminates the role of energy in bringing matter alive.
Well, when an astronaut is impressed by a biology book, you know it's good.
Seriously. But what really got me excited about Lane's work is how he kind of flips the script on us. Like, we're so used to thinking about genes as like the ultimate answer to everything in biology.
Right, like genes are at the end all be all.
Exactly. But Lane is like, hold on a second. There's a whole other side to this story. He makes a really strong case for shifting that focus to energy and matter.
It's like he's challenging us to ask, like, what really separates, say, you or me, a living being, from, I don't know, a rock or a corpse?
hmm
It's not just about having the right ingredients, right?
It's like you can have all the parts of a car laid out. You've got your engine, your wheels, your chassis, everything, but that doesn't mean you've got a functioning car, does it?
Right. It's the engine running, the fuel burning, the wheels turning, all that energy and all those moving parts. That's what takes it from a bunch of parts to an actual moving vehicle.
And what Lane is saying is that there's something similar happening at the cellular level. It's not enough to just have the genetic blueprint.
Exactly. He calls it metabolic flux, this like constant flow of energy and matter within a cell, with billions of these transformations taking place every single second. It's really incredible when you think about it.
So it's like instead of just looking at the blueprints of a building, we're diving into the actual construction site, watching the energy flow, the materials being assembled and disassembled, the whole system humming with activity.
Yeah, it's a much more dynamic picture, much more true to, the reality of what's going on.
And this is where Lane gets really interesting because he's arguing that understanding this flux, the way energy flows and transforms, could unlock some of the biggest mysteries in biology.
Mysteries like how life arose in the first place, why cancer cells behave so differently from healthy cells. I mean, he even touches on the nature of consciousness itself.
Okay, now you're speaking my language. I have to admit, the idea that something as fundamental as energy flow could be tied to consciousness, that's mind-boggling.
It really is. It makes you think about the world in a whole new way. But hold on, let's not get ahead of ourselves.
Right, right. Walk before we can run.
Exactly. Before we dive into the really heady stuff, we need to lay down some groundwork. And for Lane, that starts with challenging a very common assumption, something that we often just take for granted when we talk about the building blocks of life.
Okay, I'm intrigued. What assumption are we talking about here?
He points out a simple but often overlooked fact. A living organism and a dead one can have the exact same genetic information.
Wait a minute, are you saying that my DNA, my genetic code, is essentially the same whether I'm alive or well?
Exactly. So clearly there's more to the story than just genes.
This is where it gets really interesting for me because it forces us to ask, if genes aren't the only thing determining whether something is alive or dead, what is? So if it's not just about the genes, if this isn't just about the blueprint, what is it about that, as you said, that bustling city of the cell, that metabolic flux that really makes the difference between life and, well, not life?
Yeah, good question. Lane points to a kind of surprising place, I think, to find the answer. It's a really fundamental process. I think most of us have probably heard of it, but maybe never really fully appreciated. It's the Krebs cycle.
Ugh, yes, the Krebs cycle. Okay, so like vaguely, I remember this from, way back, biology class. It's like that metabolic merry-go-round, right? Things go in, energy comes out, round and round it goes.
That's the basic idea.
Yeah.
But what we often miss, I think, is just how dynamic this cycle really is. You see those textbook diagrams, right? The ones that depict it as just this simple circle.
Right, yeah, just a simple closed loop.
Yeah, so those diagrams, they don't really capture the full picture. It's way more interesting than that. It's more like a two-sided coin. It's capable of running both forward and in reverse.
Wait, hold up, hold up. In reverse, you're telling me the Krebs cycle can actually run backwards. Okay, now that's definitely not something they taught us in high school.
You know, kidding, right? This is where it gets really wild. And it totally changes the game. See, the forward direction, That's what we usually learn about. Breaking down those food molecules, releasing energy, and all of it ultimately relying on oxygen.
Okay, so that's like our cell's regular fuel burning mode.
Exactly. Think of it as like efficient powerhouse mode, fueling complex life, as we know it. But it's actually this reverse mode that really gets mind-bending because it actually uses energy to build, and it can build life's essential building blocks from simple molecules like carbon dioxide.
Hold on, building with carbon dioxide? Okay, that sounds a lot like photosynthesis to me.
You're on to something.
Yeah.
It's not photosynthesis
Oh.
exactly. The actual process is different, but they share that core concept of taking inorganic matter and using energy to build those organic molecules that form the very basis of life as we know it.
Okay, I think I'm having a bit of an aha moment here. So you're saying this reverse Krebs cycle, this ability to kind of build from simplicity, this might actually be like a glimpse, like we're looking back billions of years to how life itself first emerged, like to a time before photosynthesis when life had to find a different energy source, a totally different way to kickstart this whole system.
Exactly. And this is where Lang takes us on this incredible journey to some of the most extreme environments on Earth, those deep sea hydrothermal vents. Remember, these are ecosystems that are just teeming with life, but completely independent of sunlight.
Oh yeah, those things are like straight out of science fiction, giant tube worms, weird glowing creatures. It always seemed mind-boggling to me how life could even exist in those, crushing depths, no sunlight.
Right? It just totally challenges our whole idea of what life even requires. So while those ecosystems aren't completely cut off from, the sun's influence, they do highlight how life can tap into totally different energy sources.
Hmm.
So instead of sunlight, these organisms rely on chemical energy, specifically from compounds like hydrogen sulfide that spew from those vents.
So instead of basking in the sun's rays, they're drawing energy from these chemical reactions, from these vents, these kind of oozings of hot, mineral-rich water from the ocean depths. It's like a whole other kind of fuel powering a whole other kind of life.
And this is where it gets really fascinating, this idea of chemical energy driving life way back in those early days. It links beautifully with the work of Harold Morowitz and his cycling law. He proposed that energy flows, matter cycles. And the Krebs cycle, in both its forward and reverse modes, embodies that principle perfectly.
Okay, so energy is flowing from those vents, driving those early reactions, and the Krebs cycle is acting like this, like primordial engine, taking those simple molecules and using that energy to build, to organize, to essentially create life from non-life. It's like this cosmic dance, this flow of energy and the cycling of matter.
Oh, man, I'm starting to see why Lane called his book Transformer. It really is all about transformation at every level. It's such a powerful concept, right? Of course, whenever we're talking about something as complex as the origins of life, there are always challenges. There are always questions to grapple with.
Like what kind of hurdles do we need to clear to really make this connection between the reverse Krebs cycle and those first sparks of life? Okay, so we've got this picture of the reverse Krebs cycle, possibly like cooking up those first building blocks of life in those early, crazy primordial seas. But you mentioned some challenges to this whole idea. What makes it so tricky to really nail down?
One of the big things is that the reverse Krebs cycle, at least the way we see it going on, in our cells right now today, it really relies on enzymes.
Right, those like master chefs of the cell, making sure all those ingredients are combined in the right order at the right time to produce those essential molecules. But how could that even work in a world before enzymes? Back in those prebiotic days, seems like a total chicken and egg problem.
It really is, and this is where some big names, people like Leslie Orgel, they really raised some eyebrows at this idea.
Oh, yeah. What was their problem with it?
So Orgel, he was a giant in the field of prebiotic chemistry. He even went so far as to call this whole idea of like a spontaneous reverse Krebs cycle, quote, an appeal to magic.
Wow, he did not hold back.
Not at all. He argued that without those enzymes to really control and fine-tune everything, those early reactions would have been, well, a total mess, like super low yields, tons of unwanted side reactions.
It'd be like trying to bake a cake, but instead of following the recipe, you just chuck all the ingredients in a bowl and just hope for the best.
Yeah, exactly. And Orgel was very much of the mind that without those enzymes to guide everything, the odds of that cake turning out edible, let alone delicious, were practically zero.
So how does Lane respond to that? Because I gotta say, that argument, it's pretty compelling.
It is. But Lane has a really interesting counterargument. He points to all this research showing that a lot of the intermediate molecules in the Krebs cycle those steps along the way. They're actually thermodynamically favored.
Meaning?
So it means that in the right conditions, they actually have a natural tendency to form spontaneously, even without those enzymes acting as like, those meticulous chefs.
So it's like, even if you don't have a recipe or a whisk, those ingredients for the cake, they kind of want to clump together in a certain way.
That's a great way to put it. And Lane's argument is that those hydrothermal vents we were talking about earlier, with their crazy chemical gradients and unique energy sources, they could have been the perfect setting for these spontaneous reactions to start happening.
Okay, so it's less about a perfectly organized kitchen and more about a laboratory where all these ingredients are just bumping into each other and every now and then, bam, something interesting happens.
Exactly. It's like evolution had this whole playground of chemical building blocks to work with, all thanks to those messy pre-enzyme days.
This has been an amazing journey. We really just scratched the surface of Lane's ideas here, but I want to thank you for diving in with me, exploring all these, well, kind of mind-blowing concepts. I don't know about you, but I'm going to be looking at those textbook diagrams of the Krebs cycle a lot differently now.
I'm right there with you. And I think that's the power of a book like Transformer. It challenges us to rethink what we thought we knew, pushes our